In this video, we can discuss about downstream process. Downstream process is a method for the purification and extraction of desired product which are produced after the fermentation process. In previous video, we had discussed about different topics like ideal design of an fermenter, different steps of fermentation process, different culture media used for the fermentation process, and we have discussed for a fermentation process of a desired product we have to select a microorganism which is specific for that desired product, and we have to select an culture media, and in that culture media we have to carry out the fermentation process in a fermenter for a specified time which is specified for that desired product, and after the specified time we will get a product which will contain the microorganism, the metabolic end products of microorganism, desired product, and constituents of different culture media which is used for the fermentation process. So from this mixture we have to extract and purify our desired product. That step is known as downstream process. The extraction and purification of biological products from by fermentation process is referred as downstream process. It is a complex reaction and which is important as that of fermentation process. And the methodology for the downstream process depends on the nature of end products, its concentration, stability, and degree of purification. As the number of step in downstream process increases, the recovery yield will be less and vice versa. That means with minimum step of downstream process we will get maximum yield of recovery product. With maximum number of uh, downstream process, maximum steps of downstream process, we will get lower or reduced amount of recovery yield. So that is an important point we have to consider while selecting the downstream process and the steps of downstream process. Now the end product of the fermentation process will containing different metabolites as mentioned here, which may be intracellular metabolites which is usually located within the cell like vitamins and enzyme, and the metabolites may be extracellular metabolites which are present outside the cell like culture fluid. And example for this kind of extracellular metabolites are most of the antibiotics, amino acid, alcohol, citric acid, and some enzymes like amylase and proteases. Some metabolites will be both intracellular as well as extracellular, example like vitamin B12 and flavomycin. Sometimes the microorganism may be itself be a desired end product for the isolation, example like single cell proteins. Now coming to the different stages or steps of downstream process. Downstream process consists of mainly of 5 steps. First one is solid liquid separation, in which we have to separate the solid metabolites from the liquid culture media. So that is the first step. And second step is the from the separated solid desired product or desired metabolites, we have to release the intracellular product to that metabolites. And third one, after the release of intracellular products which we have separated, from that we have to reduce the amount of water or liquid. Thereby we have to concentrate the end product. And after the concentration we have to purify by different purification method like chromatographic method. And after purification we have to make to formulation to store for a long term. So these are the different steps of downstream process. Now each step we will discuss it in detail. So coming to the first step, solid liquid separation. In this we will separate all the cell as well as other insoluble ingredient from the culture broth. For intracellular metabolite, it must be released from the cell before subjecting to solid liquid separation. And different method for used for solid liquid separations are, first one is flotation. In flotation, we will introduce a gas into a liquid broth. Thereby, it will form bubbles. The cells and other solid particles get absorbed on the gas bubbles. This bubbles rises to the foam layer which can be collected easily. Sometimes collector substances which will facilitate foam formation can be used like long chain fatty acid and amino acid. So in case of flotation we are administering or we are introducing a gas into a liquid culture, thereby it will form bubbles. On that bubbles the separating metabolites can be separated. Now second method for solid liquid separation is flocculation. Flocculation can be done by different flocculating agents like inorganic as well as organic polyelectrolyte and mineral hydrochloride. So by using flocculating agents, the cells form large aggregate which will settle down, so it can be easily removed. Now, third method for solid liquid separation is filtration, which is the most commonly used method. Efficiency depends on the size of organism, presence of other organism, viscosity of medium and temperature. And this filtration can be done by using different filters. First one is depth filters, which is composed of filamentous matrix such as glass wool, asbestos, filter paper, filamentous filter paper. By using this depth filter, we can filter filamentous fungi, which can be removed by this filter. Now, next filter is absolute filter, the filter with specific forces that are smaller than the particle to be removed. By using this absolute filter, we can separate bacteria from the culture media. Now, third one is rotary drum vacuum filter, which is used to separation of broth containing 10 to 40 percentage of solid and particle size of zero point 0.5 to 10 micron. By using rotary drum vacuum filter, we can separate yeast cell and filamentous fungi can be removed. Now, next filter is membrane filter. These are the membrane with the specific pore size, and clogging is the important limitation of membrane filtration method. The three major type of filtration are used based on the particle size and characters are: microfilter is used to separate a particles of with the particle size 0.1 to 10 micron, and ultrafiltration 0.001 to 0.1 micron, and reverse osmosis 0.0001 to 0.001 micron. And next method for solid liquid separation is centrifugation. So this centrifugation is basically done on the principle of density difference between the particle to be separated. So uh, different centrifuge can be used for the solid liquid separations like tubular bowel centrifuge, disc centrifuge, multi-chamber centrifuge, and scroll centrifuge or decanter. So these are the different centrifuge which are used for the centrifugation, which is the one of the steps of solid liquid separation. And these are the First step, different method for solid liquid separation to separate the solid metabolites and product from liquid culture. Now second method is second step is release of intracellular products. The microorganism or other cell can be disintegrated or disrupted by different methods by using chemical, physical or enzymatic method. The selection of particular method mainly depend on the nature of the cell. The gram-negative bacteria and filamentous bacteria or filamentous fungi can be more easily broken compared to the gram-positive bacteria as well as gram yeast. So that is one factor according to the structure of the cell. The gram-negative bacteria can be easily broken due to its low peptidoglycan layer, and when compared with the gram-positive bacteria, which cannot be disrupted that easily when compared with the gram-negative bacteria. So different method for release of intracellular products are: first one is physical method by using ultrasonication, osmotic shock, heat shock, high pressure homogenization, embigment method, and grinding with glass beads. And by chemical method, but by using different chemicals like alkalis, organic acid and detergents. And third one is enzymatic method by using an enzyme known as lysozyme. Now coming to the first method, physical method, it can be done by either ultrasonication by using ultrasound waves, but the cost of ultrasonication is very high, so it is practically not used in the fermentation process for the industrial purpose. Second one is osmotic shock, in which the suspension of cell in 20 to 20 percentage buffer sucrose is transferred into water at about of 4 degrees Celsius. So mainly this method, osmotic shock, is used to release the hydrolytic enzyme and binding protein from gram-negative bacteria. Third method is heat shock or thermolysis by using high heat. So it is easy and cheap, but used only for few heat stable intracellular products. Next one is high pressure homogenization. This involves forcing a cell suspension at high pressure through a very narrow orifice to come out to atmospheric pressure. This sudden release of high pressure creates a liquid shear that can break the cell. Thereby it can release the intracellular product. And fifth one is embigment method. In this we will uh, uh, we will use a stream of suspended cell at high velocity and pressure, which are forced to hit either a stationary surface or a second stream of suspended cells. The cells are disrupted by the force created at the point of contact. The microfluidizer is a device which is developed based on this principle. And last method of physical method is grinding with glass. So cell is mixed with the glass bead and subjected to very high speed in reaction vessel. And this physical method can be again classified into a mechanical as well as non-mechanical method based on the mechanism used for the disruption of the cell. Mechanical method like ultrasonication, high pressure homogenization, embigment, grinding with glass beads, and non-mechanical method like osmotic shock, heat shock, chemical method and enzymatic methods are example for non-mechanical methods. Now coming to the chemical method of release of intracellular products, we will use different chemicals. So first one is alkali. Alkalis are mainly used for the extraction of bacterial proteins. Alkali stability of desired product is very crucial for the success of this method. Example for products which can be done by using alkalis are recombinant growth hormone, which can be efficiently released from E. coli by treatment with NOH. And second one is organic solvents, which are water miscible, can be used for the release of intracellular products like ethanol, methanol, isopropanol, butanol, and toluene. The toluene, which will dissolve membrane phospholipid and create the membrane pore for the release of intracellular contents. And last one is detergents. We can use cationic detergents like cetyl, trimethyl bromide, or cetrimide, or anionic surfactants or detergent like sodium lauryl sulfate, which can denaturate the membrane protein and lyses the cell. And non-ionic detergent like Triton X100 or Teen can be used to disrupt the cell detergent. By using the detergent, it will affect the purification step, particularly in salt precipitation. So that is a disadvantage of detergent. It will negatively affect while the purification step. Now, third method for release of intracellular product is enzymatic method, by using some enzyme which will lyse the cell to release the content. Example for enzyme is lysosome, which will hydrolyze beta-1,4 glycosidic bond of mucopeptide in bacterial cell wall. Gram-negative bacteria are more susceptible for the action. So by using lysosome with EDTA, which can break the gram-negative bacterial cell, and other enzyme like gluconase and mannase in combination with the protease are used for the lysis of yeast cell. Now, third method or fourth method is combination method. By combining physical, chemical, and enzymatic method, we can release the intracellular products. So this is the second step, release of intracellular product. Third one is concentration. So after the filtration or after the release of intracellular production and separation of solid liquid separation, we will get a filtrate. That filtrate usually containing 80 to 90% of water. The water has to be removed to achieve the product concentration. The different commonly used method or techniques are evaporation, liquid extraction, precipitation, adsorption. The actual procedure adopted depend on the nature of desired product, quantity as well as quantity, and the cost factor. Now first one is evaporation. In general, we will use an heating device for the supply of steam, an unit for separation of concentrated product, and vapor, a condenser for condensing vapor, and accessories and control requirements or equipments. Commonly used evaporator which are used in downstream process are plate evaporator, falling film evaporator, forced film evaporator, centrifugal forced film evaporator. Second method for concentration is liquid extraction. The concentration of biological product can be achieved by transferring a desired product from one phase of liquid into another liquid phase. So it is useful for partial purification process also. So efficiency of extraction mainly depend on the partial coefficient of two liquids which we are using for the extraction. So it is broadly classified into extraction of low molecular weight products as well as high molecular weight products. Now coming to the extraction of low molecular weight products by using organic solvent, lipophilic solvent can be extracted. This can be done by different method. First one is physical extraction, in which compound get itself distributed between two liquid phase based on the physical property. It is mainly used for the separation of non-ionizing compounds. Second one is dissociation extraction, uh, which is used to extract ionizable compounds by using two different liquids. Now reactive extraction. desired product made to react with a carrier molecules like phosphorus compound or aliphatic amine, and which is extracted into organic solvent. This method is mainly used for the compound like organic acid which are highly soluble in water, and by using supercritical fluid extraction. Using supercritical fluid which are intermediate between gases and liquid and exists as fluid above their critical temperature and pressure. Supercritical carbon dioxide with low critical temperature and pressure is commonly used for the supercritical extraction, and this is expensive, but that's why we cannot prefer in a downstream process. Now, coming to the extraction of high molecular products, the proteins are the most prominent products which will coming under the high molecular weight products. Organic solvent cannot be used for the extraction since the protein activity will be lost. So, by using aqueous two-phase system prepared by mixing polymers like polyethylene glycol and salt solution of ammonium sulfate or two different polymer. The water is the main component in aqueous two-phase system, but the two phases are not miscible. Now, another method for the separation of high extraction of high molecular weight product is reverse micellar system. The stable aggregates of surfactants molecules and water in organic acid. Protein can be extracted from the aqueous media by forming reverse micelles. And third method for the concentration is membrane filtration. So by use of semi-permeable membrane which are made up of different polymeric materials such as polyether sulfone as well as polyvinyl difluoride. But by using this semi-permeable membrane, it is very difficult to sterilize the membrane filters. So we cannot prefer the membrane filters, semi-permeable membrane filters for the filtration. So we will use micro filters and ultra filters which are composed of ceramics and steel. We will prefer because it is very easy and sterilization is cleaning and sterilization is very easy when compared with the semi-permeable membrane. And the membrane filtration can be done by micro filtration, ultra filtration and hyper filtration or reverse osmosis. And sometimes membrane absorbers, they are the micro as well as macro porous membrane with ion exchange group and or affinity ligands. Sometimes we can use a combination of evaporation as well as permeation for the separation of volatile products. So volatile products can be separated by the process of permeation through a membrane coupled with evaporation, that is known as pervaporation. Same like that, membrane filters coupled with solvent extraction is known as extraction. So these are the different method for membrane filtration. And next one is precipitation method. So concentration can be done by precipitation method by using different by used for the concentration of macromolecules such as protein and polysaccharides. It can be also used to remove some unwanted byproducts like nucleic acid and pigments. So by using, we can use different materials for the precipitation like neutral salt, like ammonium sulfate. So by using ammonium sulfate, precipitation occur by increasing the hydrophobic interaction which will result in the precipitation. So by using neutral salt we can precipitate the end product. Another solvent is organic solvent is methanol, acetone and propanol also can be used for the precipitation. The mechanism of action of precipitation is by using this it will reduce the dielectric constant of the media. Also it will enhance the electrostatic interaction which will lead to the precipitation. But we have to carry out this at 0 degree Celsius since above that this organic solvent will denaturate the proteins. Then high molecular weight polymers can be precipitated in temperature and different pH used. Then by using non-ionic polymer like polyethylene glycol, they will reduce the quantity of water which are available for the protein solvation and precipitation will occur. Then by using ionic polymers like polyacrylic acid and polyethylenamine, it will form a complex with oppositely charged protein molecule, and that can cause charge neutralization and precipitation. Now by increasing temperature, we can precipitate heat sensitive proteins, and by changing pH, which will lead to the protein precipitation. Then affinity precipitation by uh, precipitation is used for the precipitation of proteins, and precipitation by ligand also can be used for the precipitation or concentration of protein. So this is another method for concentration, precipitation, and last one is adsorption method. Adsorption can be used for the concentration process by using a solid adsorbent. Initially we were using activated charcoal, but in recently we will use advanced cellulose based adsorbents for the protein concentration. So for the concentration of low molecular weight compounds like vitamins, antibiotics and peptides, polystyrene and methacrylate and acrylate based matrices are used for the adsorption process, and it can be carried out by making a bed of adsorbent column and passing the culture through it. So that is the adsorption method. And fourth step, after the concentration process, we have to purify the end product. So for that purification, we will use different chromatographic method. In chromatographic method usually consists of a stationary phase with the porous solid matrix packed in a column, on which matrix of compound to be separated is loaded, and a mobile phase is used for chromatographic process. Now stationary phase used for the purification of proteins are agarose, cellulose, polyacrylamide, porous silica, cross-linked dextran, and polystyrene. Now different type of chromatographic methods are used for the purification method. First one is gel filtration chromatography, in which the separation or purification of protein is based on size exclusion, or based on the size and shape of the particles to be separated. And another method of chromatographic method is ion exchange chromatography, which is based on the surface charge using ion exchange resin. In ion exchange chromatography, we can use either cationic or anionic exchanger. Cationic exchangers which are negatively charged group like carboxy, methyl and sulfonate. Examples are Davox, HCr and amberlite IR. An ionic exchanger with positively charged group like diethyl ethyl amino ethyl or DEAE can be used. Example like Dovax SR and amberlite IRA. Anionic exchange resins can be used for the ionic exchange chromatography. And also affinity chromatography, in which based on the interaction of protein with immobilized ligand are used for the purification. And also hydrophobic interaction chromatography also used for the purification of the end product. And last step is formulation. Usually formulation is done to maintain the activity and stability of the biotechnological product during the storage as well as distribution. The formulation of low molecular weight product can be achieved by concentrating them with the removal of most of the water. For molecules like antibiotics and citric acid, formulation can be done by crystallizing or crystallization by adding salt. Sometimes stabilizers which are used for the protein formulations can be used as a stabilizers. Examples of stabilizers are sugars like sucrose and lactose, and salt like NaCl and ammonium sulfate, polymer like polyethylene glycol, and polyhydric alcohol like glycerol can be used as a stabilizer for the formulation of biotechnological products. And it can be stored by drying, by transfer of heat to wet product for the removal of moisture, or it can be stored by or formulated as spray drying, used for the drying of large volume of liquid. In this, small droplet of liquid containing product are passed through the nozzle, directing it over a stream of host gas. And finally, freeze drying or lyophilization, which are used for wide range of products like pharmaceutical, foodstuffs, diagnostic, bacterial, and viruses. So these are the different steps of formulation. So depending upon the desired product, we have to select any one of the uh, procedure for each step. So by doing this one, we have to consider that as the number of step of downstream process increases, the yield of product will decrease. So we have to minimize the steps in downstream process to enhance or to increase the yield of recovery products. So that we have to keep in mind while selecting the downstream process. So this is all about downstream process. Thank you for watching this video.